Hello everyone, it's day 39 and today April 11 Indian Express newspaper I have on the explained page. I found few important articles over the editorial page, but those articles were already covered in the explained page regarding the God particle, that is the Higgs boson particle. And one more particle is there which is known as neutrino, which is known as ghost particle. So we must know both the particles, what is God particle and what is ghost particle. So let us start with the reading of this explained page. First article is about the why the God particle theorized by the Peter Higgs matters. So let us see. It requires nearly 50 years and billions of dollars to detect the Higgs boson in 2012. An elementary particles like electron, quark. Okay, so this is an elementary particle, so we must know like electron, quarks, photons, and neutrinos. The Higgs boson is known to impart mass to every other particle. While its existence was predicted in the 1960s, it was found only in the 2012 through experiments carried out at the Large Hadron Collider located in the France-Switzerland border. So, Large Hadron Collider in the France-Switzerland border, the world's biggest and most expensive machine at that time. At the time, the discovery of the Higgs boson completed the standard model of particle physics. The model describes all the elementary particle and forces like electromagnetism, gravitational, or nuclear forces that build up the material part of the world. However, there are still unexplained bits like dark energy that are outside the realm of the standard model. So, who was Peter Higgs? The man after whom the particle is named, Peter Higgs, died on the Tuesday. Okay, so he died on Tuesday, is 94, and an extremely shy person. Higgs, who had started out as a molecular biologist, preferred to work in isolation and was not prolific. He never used a mobile phone or the internet. The landline at his home in Edinburgh was the only way to reach him. In 2013, on the day of the Nobel Prize in Physics was set up to be announced, Higgs did appearing act, certain that the previous year's discovery of the Higgs boson at the European Organization for Nuclear Research, that is CERN, in Switzerland. Okay, so CERN is in Switzerland. A Large Hadron Collider is in France-Switzerland border. Would fetch him the prize. Higgs left his home to avoid the attention. The Nobel Prize Committee, which informs the winners just ahead of the public announcement, was not able to reach him, and Higgs would even eventually be informed by a former neighbor who found him strolling on the street. But Higgs was not the only one behind the prediction of the Higgs boson and Higgs field. Several people contributed to the idea, and one of them was the Francis Englert, shared the 2013 Nobel Prize with him. Okay, so Francis Englert, who shared the 2013 Nobel Prize with him. So why is Higgs boson called God particle? The Higgs boson is the mostly known as God particle. The expression was first used by the Nobel Prize winning physicist Leon Lederman, who wrote a book by the title in the 90s about the continuing search for the particle. While Lederman wanted to call his book the Godman particle to describe the Higgs boson's elusive nature, his publishers persuaded him to go in the God particle instead. The name that has stuck. Many scientists detest this expression due to the particle acquiring religious connotation in some circles because of that name. So why does the Higgs boson matter? Boson boson is the name given to a family of electron elementary particles known to be a carrier of fundamental forces like electromagnetism. A photon which carries the electromagnetic force is a boson. Matter particles like electrons or protons belong to the class called fermions. The Higgs boson is significant as it is the particle which accounts for the mass of every other fundamental particle. Mass is not the something that is intrinsic to matter. Fundamental particles like electrons do not have mass within themselves. In the 1950s 60s, when the standard model was still being developed, scientists realized that the equation did not work if these particles had inherent mass. It was a mathematical model problem that Higgs and several other scientists worked on, and in 1964 separately developed the idea of an of an all pervasive field, just like an electric or magnetic or gravitational field in which a massless particle could gain mass. The preeminence that Higgs received was mainly because he alone postulated that the mathematical construct, if it were a physical reality, would give rise to a particle, the eventual Higgs boson. As it became clear later, it is the interaction of the particle with this Higgs field, the way they change the field or get changed by them, that lends them the mass. The greater the interaction, the larger the mass. Different particle interacts with this field in different ways, and that is what gives them different masses. A photon, which is a light particle, does not interact with this field at all and is thus massless. There are other particles that are massless as well, but particles like electrons and protons do interact with and have masses. The Higgs boson itself interact with the field and has mass. Okay, so Higgs boson itself interact with the field and it has mass. The concept of the Higgs field and the Higgs particle are not very intuitive, but these are the fundamental to our current understanding of how nature works. The main frame, the main fame for the Higgs boson came from its elusive nature. After nearly 5 decades of searching, the particle was finally found at the Large Hadron Collider, the world's biggest particle accelerator. So it was found there. So we must remember these two names: what is known as God particle, what is known as uh, ghost particle, and most important, what are the elementary particles. Protons and neutrons are not elementary particles, we should remember that, but electron is. So another important article is about the time standard for moon's surface. So let us see what it is about to say. The White House has directed NASA to create a time standard for the moon, okay, which which international organization and private companies can use to coordinate activities on the lunar surface. The space agency has been asked to work with other parts of the United States government to finalize by the end of 2026 their strategy establish a coordinating lunar time. So first, how the time standard for Earth works. Most clocks and time zones are based on the coordinated universal time, which is set by the International Bureau of the Weights and Measures in Paris. So okay, so uh, International Bureau of Weights and Measures is in Paris. So UTC is essentially an internationally agreed in standard for world time. So UTC is tracked by a weighted average of more than 400 atomic clocks placed around the globe. Atomic clocks measure time in the terms of resonant frequencies, the natural frequency of an object where it tends to vibrate at a higher amplitude of atoms such as the cesium 133. So cesium 133 is used for atomic clocks, okay. So in atomic time, a second is defined as the period in which a cesium atom vibrates 9 919263177 times, okay. So as the vibration rate at which atoms absorb energy are highly, so this is important thing in atomic time. A second defined as the period in which cesium atom vibrates this much time. So as vibration rate at which atoms absorb energy are highly stable and ultra accurate, atomic clocks are excellent for gauging the passage of time. To obtain their local time, countries subtract or add a certain number of hours to UTC, depending on how many time zones away from the 0 degree longitude meridian, also known as Greenwich meridian, they are. If a country is to the west of the Greenwich meridian, it has to subtract from UTC. Okay, so in the west it has to subtract, and in the east it has to add. Like India is at the 82.5 degree east, so it has around 5.5 hours ahead plus add to the UTC. So if a country is to the east of the meridian, it has to add. So why do we need a time standard for the moon? So time flows differently on the moon and cannot be determined using UTC, as because time is relative and it has impact due to gravity. So fundamental aspect of nature is that universe is that time is not absolute. That seems crazy to us on Earth, as our experience of time is that it just constantly ticks by. But if you travel to the moon, your clock would be ticking slightly faster. This is a consequence of Einstein's theory of general relativity, which tells us that gravity bends space and time. As there is less gravity on moon, time ticks slightly faster there relative to the Earth. Catherine Hemans, astronomer, Royal for Scotland and professor of astrophysics at the University of Edinburgh, told that Indian Express by email. Thus, on the moon, an Earth-based clock will appear to lose on average 58.7 milli 57.58.7 microsecond per Earth day with additional periodic vibrations. According to the memo issued by the White House Office of the Science and Technology Policy, this may seem like a teeny discrepancy, but it is enough to create a problem for a spacecraft trying to dock on the moon, transfer out data at a specific time, navigation, and communication. So currently, each lunar mission uses its own time scale that is linked to UTC. Take the example of two spacecraft, NASA's Lunar Resonance Orbiter. Okay, so NASA's lunar and ISRO's Chandrayaan 2 orbiter, which orbit the moon, is roughly similar polar orbit, which with some overlap. So each lunar mission uses its own time scale that is linked to UTC. Okay, okay. So which orbit the moon in roughly same. Okay, to ensure that they do not collide, the probability of this is low, but it can happen. The two mission control teams talk and synchronize their operation standard as needed based on the differences in the way they calculate the orbits and time, etc. Jatan Mehta, a space exploration writer and the author of the Moon Monday newsletter, told the Indian Express. While this can work for a handful of independent lunar missions, there may be a problem with multiple spacecraft working together at the same time, a situation that will soon become reality. Several countries, including India, have lunar missions lined up. NASA's Artemis program aims to send humans back to moon after September 2026, and China and India intend to send their own astronauts to lunar surface by 2030 and 2040 respectively. A long-term human outpost too is planned for the moon. So how will the lunar time standard be established? The specifics are not clear yet. A White House official told Reuters that, like on Earth, atomic clocks could be deployed on the moon. A report by the journal Nature published last year said at least three atomic clocks ticking on the moon's natural pace would have to be put on the lunar surface, the output from which would be combined by an algorithm to generate a more accurate virtual timepiece. These clocks have to be placed at locations since the moon's rotation and even local lumps of mass called mascons beneath the crust of the moon affect the flow of time slightly. Mehta said, mascons or mass concentrations, okay, or mass concentrations are so dense that they alter the moon's local gravity field. The output from these clocks can be synthesized to give moon its own time, which can be tied back to UTC for seamless operation from Earth. Even on Earth, atomic clocks tick at different rates because the Earth's rotation speed varies from equator to poles, which also affects time. The Earth rotates faster at the equator than at the poles, as it is wider at the equator. So that we know. So that was very important article. So a new time zone is being created to for the moon. So let us see. There's another important article about the curative relief for Delhi Metro. Delhi Metro. So what this article is about to say. So the Supreme Court has overturned its 2021 judgment and upheld an arbitral award in a commercial dispute, sparing government from having to cough up to rupees 8,000 crore. What is this case? History of Supreme Court curative jurisdiction. Let us see. Supreme Court on Wednesday ruled that the Delhi Metro Rail Corporation (DMRC) will not have to pay rupees 8,000 crore to the Delhi Airport Metro Express Private Limited, an Anil Ambani-owned Reliance infrastructure company, which was awarded by a 2017 arbitral award. The ruling overturned the Supreme Court's September 21 judgment that upheld the arbitral award. A month after the judgment, the court had dismissed the plea seeking a review, the final step in the appeal process which, after a ruling of the highest court, attains finality. So, review is under the Article 137. Curative petition is Ashok Hura versus Rupa Hura. So, what is the history of the case? Um, the court now exercises extraordinary powers in a curative writ petition to correct a fundamental error in its judgment. So, history of the case: in 2008, the DMRC entered into a public-private partnership with the DAMEPL, which is about Delhi Airport Metro Express Private Limited, a consortium led by Reliance Infrastructure Limited for the construction, operation, and maintenance of the Delhi Airport Metro Express. While DMRC acquired the land and bore the cost of construction, the consortium was to design, install, and commission the railway system into 2 years. Thereafter, until 2038, DAML was to maintain the line and manage its operation while paying a concession fee to DMRC. However, a year after the line became operational, the consortium asked DMRC if it could defer payment of the concession fee. Among the reasons cited were delays in the providing access to stations by DMRC, and that retail activity has had not picked up on the line. This triggered a dispute between consortium and the Union Ministry of Urban Development. Subsequently, Barely a year into its operation, the line was shut following a complaint from a Dampel that it was unsafe to operate. The consortium triggered a termination of its agreement, alleging that alleging there were technical problems in the civil structure of the metro corridor for which DMRC was responsible as per the agreement. Before operation were finally handed over to DMRC in June 2013, the Dampel and DMRC made a joint. Okay, so rulings of the court is not that much important. So, what is about the curative jurisdiction? We should know that first, especially petition is there under Article 136, and then a curative petition, not curative petition, then a review petition can be filed under Article 137, and if it is rejected, then Supreme Court had designed a new tool for its own purpose in the 2002 Ashok Hurra versus Rupa Hurra case, in which the concept of curative petition was designed. So this has been finally exercised by the Supreme Court in this case. So curative petition is about that. So curative petition is not directly mentioned in the constitution, but it has been a tool designed by the Supreme Court itself. So that's all from today's newspaper. I didn't find anything else important in this newspaper today's newspaper. So we'll meet tomorrow.